Welcome back to Ctrl+Talk. Today, we're going on a deep dive into the world of web servers, specifically NGINX, pronounced NGINX, and Traefik, pronounced Traefik.
Right.
So whether you're a quirk or no,
Yeah.
trying to get up to speed on web infrastructure, or just curious about what makes the internet tick, I'm going to break down the key differences between these tools and really explore why they matter so much.
Yeah. I think what's so interesting here is that you're really looking at, a seasoned veteran
In the tech world.
and a rising star, and they both essentially manage and direct web traffic, but they have very different approaches and different strength.
Yeah.
And they really cater to different needs and different scenarios.
Okay, let's unpack that.
So
Let's start with the veteran. NGINX, it's been around since 2004, and was created to tackle a challenge known as the C10K problem.
yeah, the C10K problem was a significant hurdle in the early days of the internet. You have thousands of users trying to access a website simultaneously. Most servers at the time simply couldn't handle that, and the result was slow websites, crashes.
Just lots of frustrated users. NGINX was specifically designed to address this by acting as a super efficient traffic hub, ensuring a smooth and efficient distribution of requests.
So essentially preventing websites from buckling under the pressure of traffic. But what makes it so efficient? What's under the hood?
So NGINX utilizes something called an event-driven architecture, which means it doesn't rely on threads for each connection. And this approach is incredibly resource efficient, allows NGINX to handle a massive number of connections without breaking a sweat. Its stability and performance under pressure are some of the key reasons. It's so widely adopted, it towers over 40% of the top 10,000 websites globally. Wow, 40%.
Yeah. A pretty impressive market share. It sounds like it's really earned its reputation for reliability. But let's bring in the rising star now. Traefik entered the scene 2016. A time when the web development landscape was undergoing a pretty significant shift.
Yeah, and Traefik really reflects that shift. It's designed for the world of microservices and containerized environments. It integrates really seamlessly with tools like Docker and Kubernetes. These technologies represent a move toward flexible, modular, scalable application architectures. And Traefik is built to thrive in that world.
So if NGINX is the seasoned veteran, Traefik is the agile newcomer, designed for the modern web, especially the cloud. But how do their approaches differ in practice? Let's start with configuration.
Yeah, configuration is where we see one of the key distinctions. So NGINX typically relies on manual configuration. So this means developers or system administrators need to actually edit configuration files whenever changes are required. Traefik, on the other hand, embraces dynamic configuration.
Dynamic configuration. Does that mean it configures itself?
In a way, yes. Traefik can automatically detect and configure routes for your applications and services by integrating with platforms like Docker and Kubernetes. So as you deploy new containers or you update existing services, Traefik adapts in real time, and this eliminates the need for any manual intervention.
Okay, so if you're working in a fast-paced environment where things are constantly changing, Traefik could save you a lot of time and headaches. But for someone who prefers a more hands-on approach, NGINX might be the better option.
It depends. While NGINX's manual configuration might seem like more work up front, it does provide a higher degree of control and predictability, which can be crucial for some applications.
It's a trade-off between control and convenience. Interesting. What about monitoring? How do these tools stack up when it comes to keeping an eye on performance?
This is another area where we see their approaches differ. So Traefik comes with built-in monitoring and metrics. So this provides a really clear window into its performance, allows you to easily track key indicators. NGINX, on the other hand, typically requires third-party tools for detailed performance monitoring.
So if you're using NGINX, you might need to invest in additional tools and set those up to gain those insights, which could add complexity, potentially.
Increase costs.
That's right. The built-in monitoring in Traefik makes it much easier to troubleshoot issues, optimize performance, and gain a really comprehensive understanding.
Right.
Of your web traffic, this is particularly valuable in dynamic environments where that visibility is so crucial.
Right, so we've covered configuration and monitoring. But beyond these core functions, are there other key distinctions that someone should be aware of? Absolutely. One crucial difference lies in their initial design goals. So NGINX, as we discussed, was really built to solve that C10K problem, focusing on handling a large volume of requests efficiently. Traefik, on the other hand, was born in the age of microservices, and emphasizing seamless routing and management of traffic between these interconnected services.
So if your application is built,
Right.
like a network of smaller independent services, Traefik seems like a more natural fit.
Exactly. Traefik excels at automatically discovering and configuring routes for microservices. And this really simplifies the management of these complex deployments. While NGINX can certainly handle microservices, Traefik was really specifically designed for this modern architectural style.
So it sounds like each tool
Mm.
reflects the needs and trends of the time it was created. So NGINX for the era of monolithic web applications and Traefik for the rise of microservices.
Yeah.
And the cloud. What about community support do these tools have? Thriving communities behind them.
Yeah, community support is crucial, especially when you're working with, complex technologies like these. NGINX, being the older and more established tool, boasts a larger and more mature community. There's a wealth of documentation, online forums, experienced users who are ready to help.
So if you encounter a problem or need guidance, you're more likely to find a solution within the NGINX community.
Exactly. That vast pool of knowledge and experience can be invaluable. However, Traefik's community, while younger, is rapidly growing. There's a lot of enthusiasm, active development happening, making it a vibrant space for learning and sharing.
So even though it's newer, Traefik still has a dedicated and supportive community behind it. That's good to know. We've covered a lot of ground here. But it's important to remember that choosing between these tools isn't about finding the best one, but rather the one that best suits your specific needs and the environment you're working in.
Absolutely. So if you need a robust, battle-tested web server with a long history of reliability and performance, and you prefer manual control over configuration, NGINX might be the ideal choice.
Especially if you're working in a more traditional environment where things are relatively stable. But if you're embracing the world of microservices, containers, and dynamic cloud deployments, try out ease of use, dynamic configuration, and built-in monitoring might be a more appealing option.
Precisely. It's about selecting the tool that aligns best with your project's requirements and your team's workflow. Both tools are powerful in their own right, and understanding their strengths and differences is key to making an informed decision.
Now, before we move on to part 2 of our deep dive, where we'll explore real-world examples and use cases, we'll take a moment to reflect, grab a drink, jot down any questions you have, and we'll be right back to explore the practical applications of NGINX and Traefik.
Welcome back. It's time to bring NGINX and Traefik to life with some real-world examples.
Yeah, love seeing how these technologies play out in actual scenarios. It helps to solidify the concepts. So let's start with NGINX. What are some of the classic ways it's being used out there in the wild?
Well, one of the most common uses of NGINX is as a web server. It's the foundation of any website you visit. And it's renowned for its speed, stability, and ability to handle, those massive traffic spikes? Think about popular e-commerce sites during a flash sale or media streaming platforms when a new season of a hit show drops.
It's essentially, if a website needs to stay up and running smoothly even when thousands and millions of users are trying to access it at the same time, NGINX is a go-to solution.
Exactly. NGINX ensures that web pages and static content are delivered quickly and efficiently, even under immense pressure. That's why it's the
backbone of so many high-traffic websites.
Okay, we touched on this earlier, but I'd love to dive a bit deeper into how NGINX operates. As a load balancer, sure, so picture this. You have multiple servers running your application. A load balancer acts like a traffic director, distributing incoming requests across these servers to prevent any single server from getting overwhelmed.
So it's like having a team of chefs in a busy restaurant.
And the load balancer is the maître d', ensuring that each chef gets a manageable number of orders.
At the perfect analogy, the load balancer ensures that no single server is overworked, leading to a smoother experience for users. And NGINX is a highly sophisticated load balancer. It can take into account factors like server load, geographic location, even specific application logic to distribute traffic intelligently.
So it's not just randomly assigning traffic, but it's actually making strategic decisions based on various factors to optimize performance. That's impressive.
Exactly. That intelligence is a key part of what makes NGINX so effective at maintaining website availability and performance, even during peak usage times.
Okay, so we have the web server role and the load balancer role. Any other common use cases for NGINX we should explore? Another frequent use case is as a reverse proxy. So this is where it acts as a sort of intermediary between users and your web servers.
Reverse proxy, that term always throws me off a bit. Can you refresh my memory on what it does?
Okay, so imagine a security checkpoint. At a building, a reverse proxy acts in a similar way. It sits in front of your web servers, and it handles incoming requests from users. It can perform tasks like caching frequently accessed content, filtering out malicious requests, and even handling SSL encryption for secure connections.
Okay, so it's like having an extra layer of
Well,
security
because
and efficiency in front of your web servers, protecting them and optimizing performance.
Precisely. It adds a layer of separation between the outside world and your servers, enhancing security.
Right.
And by offloading tasks like SSL encryption to the reverse proxy, your web servers are freed up to focus on running your application logic.
It's amazing how one tool can wear so many hats. In web infrastructure world, NGINX sounds incredibly versatile.
It is. That versatility is one of the key reasons why NGINX has remained so popular for so many years. It's a reliable workhorse that can handle a wide range of tasks.
All right, let's switch gears now and talk about Traefik, the rising star. We've talked about its dynamic configuration and how it's built for the world of microservices and containers.
Yeah.
But how does that translate into real-world applications?
One area where Traefik truly shines is in containerized environments, particularly when working with tools like Docker and Kubernetes.
Now, for those who might not be familiar with containers, can you give us a quick rundown of what they are and why they're becoming so popular?
Okay, so think of containers as lightweight, portable packages that contain everything an application needs to run. It's like having a self-contained mini environment for each application, making them incredibly flexible and easy to deploy.
So it's like shipping an application.
Yeah.
It's a little box ready to run anywhere.
Exactly. Tools like Docker make it easy to create, manage, and deploy these containers, and they've become a cornerstone of modern application development.
And how does Traefik fit into this containerized world?
Traefik acts as an ingress controller for container orchestrators like Kubernetes.
Ingress controller, another term that might need some clarification.
Yeah.
For our listeners, what exactly is an ingress controller?
So imagine a busy airport with multiple gates. An ingress controller is like the air traffic control system. It manages all incoming traffic and directs it to the appropriate destination within the airport, ensuring things run smoothly.
So in the context of containers and Kubernetes, the ingress controller manages all the incoming requests and routes them to the correct container or service.
Exactly. And Traefik is particularly well suited for this role because of its smart dynamic configuration capability. So as new containers are created or removed, Traefik automatically adjusts its routing rules without requiring any manual intervention.
So it's like Traefik is constantly monitoring the airport, making sure that each incoming plane is guided to the correct gate, even as the airport layout changes dynamically.
That's a great way to put it. This ability to adapt to changes on the fly makes Traefik a favorite among developers who are working with containerized applications and microservices.
You mentioned microservices earlier. Can you explain how Traefik specifically addresses the challenges of managing traffic in a microservices architecture?
Sure. So, in a microservices world, you often have numerous small, independent services that need to communicate with each other. So think of it like a city with lots of interconnected neighborhoods.
And without efficient traffic management, things could get pretty chaotic.
Absolutely. Traefik acts as a central traffic manager. For this city of microservices, it automatically discovers these services and configures the necessary routing rules to ensure that requests are directed to the correct destination.
So it's like having a sophisticated navigation system that guides all those requests through the complex network of microservices, making sure they reach their intended destination.
Exactly. And this dynamic routing capability is essential for managing the complexity of microservices architectures, especially as they grow and evolve.
Okay, I'm starting to see the appeal of Traefik for modern application development. But can you give us a concrete example of how it might be used in a real-world scenario?
Sure. So imagine you're building a ride-sharing app like Uber or Lyft. You might have separate microservices for managing user accounts, mapping and location services, ride requests, payment processing, and driver communication.
So instead of one giant application, you broke it down into smaller, specialized components.
Exactly. Now, when a user opens the app and requests a ride, Traefik can automatically route the request to the appropriate microservices. So it might first go to the user account service for authentication, then to the mapping service to find nearby drivers, and then to the ride request service to match the user with a driver.
So Traefik acts like the behind-the-scenes orchestrator, making sure all these different parts of the app work together seamlessly without the user even realizing it's happening.
That's precisely it. And as your app grows,
And you add.
new features or services, Traefik effortlessly adapts, ensuring that traffic flows smoothly and efficiently.
Traefik truly seems to be built for the dynamic, ever-changing nature of modern applications. Its ability to adapt to changes in real time is impressive.
It is. It's all about simplifying the complexities that come with modern application architectures and making it easier for developers to focus on building great software.
Welcome back to Ctrl+Talk. So, we've explored the strengths, weaknesses, real-world applications of NGINX and Traefik. Now, let's shift gears a little bit and look towards the future. What lies ahead for these powerful web servers?
The exciting thing about technology is that it's constantly evolving, and both NGINX and Traefik are continuously adapting to keep pace with this changing landscape of web development. For instance, NGINX, despite being the veteran, is actively enhancing its capability to better support modern architectures like microservices and containerized environments.
So they're not just sitting back and relying on their past successes. They're actively working to stay relevant in the face of newer tools like Traefik.
Exactly. You know, NGINX is investing in features that really bridge the gap with the cloud-native world. And on the Traefik side, we see a strong emphasis on performance, scalability, security enhancements. They're working to really solidify their position as the go-to choice for these modern, dynamic deployments.
It sounds like healthy competition is driving innovation, which ultimately benefits everyone who uses these tools.
Absolutely. As NGINX and Traefik continue to evolve, users gain access to better features, improved performance, and just more options to really tailor their web infrastructure to their specific needs.
Now, let's zoom out a bit. Beyond the specific features of these tools, what are some of the broader trends shaping the future of web infrastructure as a whole?
Well, one of the most significant trends is the continued rise of cloud computing. More and more applications are migrating to the cloud, and tools like NGINX and Traefik need to adapt and need to seamlessly integrate with major cloud platforms like AWS, Azure, Google Cloud.
So being cloud native isn't just a buzzword. It's becoming a necessity for these tools to thrive in the future.
Precisely. Cloud integration means supporting features like auto-scaling, where your web infrastructure automatically adjusts resources based on demand, and dynamic provisioning, which allows you to quickly deploy new servers and services as needed.
So it's like having a web infrastructure that can breathe and adapt on its own, responding to changes in real time.
That's a great analogy. And this level of flexibility and responsiveness is essential. In the cloud era, another critical trend is the increasing importance of security as cyber attacks become more sophisticated. Web servers are on the front lines of defense.
So security can't be an afterthought anymore. It needs to be built into the core of these tools.
Absolutely. Both NGINX and Traefik are incorporating advanced security features. We're seeing things like web application firewalls to filter out malicious traffic, more granular access controls to restrict who can access what, and robust authentication mechanisms to ensure that only authorized users get
So it's like having a security detail guarding your web infrastructure around the clock.
That's a good way to visualize it. And this proactive approach to security is essential in today's threat landscape. But it's not just about the technology, it's also about the people who use it. So how are the roles of developers and system administrators evolving in this world of increasingly automated web infrastructure?
That's a great question. Are developers taking on more operational responsibilities? And are system administrators becoming more involved in the development process?
We're definitely seeing a shift toward DevOps practices, where development and operations teams work more collaboratively. Tools like NGINX and Traefik, with their focus on automation and self-service capabilities, are empowering developers to take on tasks that were traditionally handled by operations teams.
So it's less about distinct silos and more about a shared responsibility for building,
deploying,
and managing applications.
Exactly, and this blurring of lines between development and operations is leading to new skill sets and roles emerging in the industry.
So if you're interested in working in this field, it sounds like you need to be comfortable with both the development side and the operational aspects of web infrastructure.
Absolutely. The future belongs to those who can bridge that gap and embrace a more holistic view of the software development lifecycle.
This has been a fascinating exploration, not just of NGINX and Traefik,
That's
but also of the greater forces shaping the future of web infrastructure.
Yeah, we've covered a lot of ground, from the technical intricacies of these tools to the trends of cloud computing, security, DevOps, and what's clear is that this field is constantly evolving.
The learning never stops. So as we wrap up this deep dive, what's one key takeaway you'd like to leave our listeners with?
Okay, so here's something to ponder. Imagine a future where web infrastructure is truly self-managing. It adapts to changing demands in real time, optimizes performance on its own, and automatically mitigates security threats. We're not there yet, but tools like NGINX and Traefik are paving the way for that future.
That's a future I'd love to see. A future where the web is more intelligent, more efficient, and more secure.
Precisely. And that's an exciting journey to be a part of.
Well, we hope this deep dive have given you a solid understanding of NGINX and Traefik, their strengths, their differences, and their place in this ever-evolving world of web infrastructure. Keep exploring, keep learning, and stay curious about the future of the web. Until next time.
Happy coding.